Yeah, now we are live on YouTube. Let me just confirm and we will start the session. Okay. So today we will be discussing about KiCAD and I have a I have a presentation with me. So this course will be going to be very practical, not just a theory. We will be also discussing the practical applications as well. Yeah, I think our stream is going fine. Okay. So can you just confirm you are able to hear me, right? Just a quick confirmation so that I will start. You are able to hear me, right? Nihal Reddy, can you hear me? Okay, okay. Thanks for the confirmation. Ayub, what happened? Ibrahim and others not joined the session. Can I just notify them because they will be missing the session.
I don't know. I don't know the reason why they are not joining, but I think they will soon join.
Okay, okay. So no worries. Yeah. So I will tell you. So KiCad is also one of the widely used. Last time, those who attended the previous course, that for beginners, we have already ran a course like 30-day PCB design challenge, where we have given you the basics of PCB designing, how to use ECEDA, and lots of interesting things we have learned. So the chemistry behind the manufacturing process and everything. So this time we will be using KiCad. So this KiCad is also open source, unlike Altium Designer. So KiCad doesn't require any kind of license to install the application on your device. So for that you need to, this is the official website of the KiCad. So www.kicad.org. Okay. So yeah. So once you, this is the main official website of the KiCad. Here there would be download option. So the first option would be documentation, where you can see the documentation as well. So click on download option and choose the operating system, whether you are using Windows, Mac OS or Linux or Docker. So let's say I'm using Windows, then I will go with the Windows option. Okay. Yeah. So this is, see, current the stable version is 10. Current version is 10.0.4, which is the stable version. So KiCad supports Windows 10 and 11. You can, if you are doubt whether your system supports the KiCad or not, so here is a separate link, system requirements. Go through these specifications. Okay, these all are the requirements for that your hardware must support. So if your hardware specifications is matching with these listed requirements, then you can run the KiCad on your system, or else you need to change the system. You need to upgrade the system. Okay, so yeah, this is the there are multiple servers through which you can download CERN server. Okay, I just don't know whether you know about CERN or not. So actually the first website. So right now we are learning about web developments and lot of things, right? HTML, CSS, JavaScript, web development, web technologies. Actually, the first website was built at CERN only. Okay, CERN. So you can still visit their website, like the first website which is ever built in the history, that is still existing. You can also go and check out that website, which was actually built at CERN only. Okay, so there are different servers. So if you are in China, you can go with Alibaba Cloud, because Alibaba is very famous in China, so the server would be very fastest. So you can use any one of these server, no issue. You can go with any one of these servers. So let's say I'm going with GitHub. Okay, so you can go with any server. Let's say one server, at one server, if the installation is going very too low, I mean the download speed is too low, then you can choose any alternative server as well. Okay, yeah. So usually the setup takes around 2 hours. Okay, usually the downloading itself takes 2 hours around. So it's actually, sometimes it may take more than 2 hours, but on an average it will take around 2 hours. So now I will be showing you about KiCad, what are the features of KiCad and everything. We have an exciting PowerPoint, exciting presentation on that. So let's go with it. Okay. Yeah. So I hope you are able to see my screen, right? Ayub, I hope you are able to see my screen, right? Okay. So today we will be learning about all these are advanced lectures. Okay. So today is just an introductory session. In the upcoming sessions, we will be learning completely like tomorrow we will be doing the installation of KiCAD. Okay. So then after we'll be directly without no theories and nothing. Directly we'll be jumping into how to use KiCAD and what are the different features of KiCAD. So no more theory. Already the theory is covered in the previous session where we have learnt about lots of so many things, right? Yeah. So this course is powered by Suchana Space Expo in collaboration with Groyota LLP and Ergel Technologies, Luna Energy, co-presented by Anu Electronics. So thank you for enrolling into 28 days PCB design course with KiCAD, and this is your expert mentor Hemant Abhiram from Suchana Space India Laboratories. So, so this is the outline. So we are learning about so many things, comparison of KiCAD to other programs. There are so many PCB designing softwares like ECEDA, Altium Designer, Eagle. So there are so many. So we will be having just a quick comparison between ECED and KiCAD and other programs. So what are the drawbacks to be aware of in KiCAD? So even KiCAD also having some drawbacks. So what are those drawbacks that we should need to be aware of? And how is the workflow options, symbols, footprints? So actually we haven't learnt much about symbols and footprints in ECEDA, right? But which we will be learning in KiCAD course. And component suppliers like and BOM consideration. So there are different component suppliers. We will be also learning about all these things. Mouser, DZKey, which are very famous, Octopart. So I hope you remember in ECEDA we have used something like LCSC library. So from LCSC library, with the help of manufacturer part number, we have placed the components, right? But here we are having so many component suppliers, not just LCSC. We are having Octopart, we are having Farnell, Mouser, DigiKey, RS, and so many things. So we will be also learning about a few manufacturing houses which are there in UK and one in China. So we'll be learning about KiCAD installation and schematic editor setup. So this is the basic outline of the today's session. However, we are still splitting it into two different segments. Tomorrow we will be learning about KiCAD installation and schematic editor setup. Okay. Yeah. So welcome to the introduction to KiCAD. So if you want to install KiCAD on your system, I have already shown you. This is the official website www.kicad.org. You can go here, and the second option is the download option. There you can click and you can choose your operating system, and you can directly download the executable file. Then you can do the setup, and then you can install KiCAD in your system. So if you have any questions related to KiCAD, there is a huge community, there is a forum where you can freely post the questions related to the KiCAD and PCB related things. So to do, for any help, there is a huge community. You can visit the official website https forum.kicad.info. Okay, this is the official website where you can post any questions related to KiCAD. It's a huge community. There, all your questions will be definitely answered by an expert team. Okay. Yeah. So KiCad is actually began, the development began in 1992. Okay, he is the person behind that, Jean Pierre Charras. Since 2015, it is managed by this particular person and a team of developers, including at CERN. Okay, so CERN is one kind of organization where actually some, most of the time researches happen. Okay, research and development. See, this is the official website of CERN. Okay. Don't worry, this is just an introductory session just to uh, we will also have some interactive session. I will be also speaking with you everyone individually. Okay, from tomorrow everything would be completely right after the installation of KiCAD. Everything will be in practical. Okay, so we'll be giving less priority to theories and we'll be giving more priorities to application in this course. Yeah, it is server is taking some time to load. So meanwhile we'll go through it. So it is a open source unless unlike Altium Designer, it is completely open source. Anyone can install in your system and you can do whatever the PCBs you want. If you know, there's a huge community for Altium Designer. You need a license, isn't it? If you want to install Altium Designer in your system, you need to obtain the license from Altium. However, they are providing some licenses free trial version for students and hobbyists, but still it doesn't help you because to complete a project it may take a little bit more time, longer time frame, which may not be suitable. If you go with a trial version, it may not be suitable. Even if you are a student, to install the Altium Designer, you need to uh, prove your identity. You need to authenticate yourself. Like uh, you need to submit your email ID, which is issued by your college, and you need to upload some ID proof. So they will be scrutinizing your details, and then they will be approving it. So it's not that much of a simplicity to obtain free licenses. Yeah. So other programs versus KiCad. So we are many of you also know about Autodesk Eagle. Okay, Altium Designer. So these are actually by Altium. So very popular free version available, similar in features to KiCad, more advanced in some ways, and widely supported. See this Altium Autodesk Eagle. Okay, this Autodesk Eagle is also widely used. So just like KiCad, this Eagle is also free version. Okay, free version is available. So we have a premium version as well as free version is also available. So many of the features are very in Autodesk Eagle. So many of the features are very similar to KiCad only, but some features are more advanced in certain ways. Okay, and it is also widely supported. So, but every new version since Autodesk Takeover gets more locked down. So free version limited in layer count and board size. KiCad can quite well import Eagle projects. Okay, this is very important to understand. So Autodesk Eagle is one kind of PCB designing software, and Altium Designer is another thing. Altium Designer is by Altium team. So we have Eagle as well, which is powered by Autodesk. So Autodesk is a free version available for Autodesk, and it is very popular. So many of the features are very similar to KiCad, but some features are more advanced in some ways, and it is also widely supported. And free version is having only limited number of limited functionalities, like let's say layer count. So there would be restriction on the number of layers that you are using. So you cannot use as many as layers that you want if you are working on a multi-layered PCB. So for board sizes also there are some restriction. Okay, so you must follow those provisions. You cannot go beyond those. If you want to go beyond, then you need to opt in for a premium version. But coming to KiCad, it is very stable. Okay, so in Autodesk, as they are upgrading the version, so as the version increases, so some of the features are being locked down. But only KiCad is maintaining the functionalities very stable. So that's why KiCad is very stable compared to Eagle and other things. Okay, but Eagle is having some advanced features. If you are in necessity of those advanced features, you can go with the Eagle. Okay, now we will go with the Altium Designer. See, Altium Designer is also regarded as the professional PCB design tool. Okay, it is very professional PCB design tool. So, Altium Designer is also conducting so many webinars to teach about to introduce Altium to students and community. So, if you are interested, you can go, you can register for their webinars as well. So, experts from Altium will be giving you a brief intro. Probably they will take only one session. So, they will be giving you the intro as well. So much more advanced professional level features that KiCad lacks. So what are those certain features which are not there in KiCad? For example, controlled impedance, stack up management, integrated parts database, etc. These are actually absent in KiCad, but these are present in Altium Designer. It is having the user interface is very good, extremely good. The user interface of Altium Designer is designed so perfectly. Okay, and recommended starting with a simpler tool like KiCAD. So we recommend you kindly directly don't jump into ECAL or other advanced tool. So those who completed ECEDA, where we have taught you the introduction to PCB designing uh, in 30-day PCB design challenge course by Suchana. So where we have taught about ECEDA and different manufacturing processes, silk screen layers, so routing and track with derivation formula. Yeah, someone trying to join the meet. Yeah. So in the previous course, we have taught you so many interesting things, right? So with that knowledge, now you are safe to proceed to KiCAD. Okay. So after completion of KiCAD, then I request you can get a license. Okay. For Altium Designer. So just install your Altium Designer in your systems, and we will, if you can opt in for Altium, you can teach Altium as well. But as of now, we are proceeding with the KiCAD course. So yeah. Now the next concept is interoperability. Okay. So from mechanical CAD, you may be familiar with the step or IGS files. So how many of you know about the step files? Any idea? Step files. Any idea about step files? Have anyone worked on CAD tools? You might let's say if you are doing some engineering or you are done with engineering, you might have remember that in your olden days or during your engineering time, you might have worked on some CAD tools, right? So Autodesk. So do you remember CAD tools? So Nihal, you remember Autodesk or any kind of Fusion 360? So where we can do modeling, 2D modeling, 3D modeling. Uh, we can draw shapes. You remember Nihal?
No, sir, I have not done with them.
Oh, okay. So Prakash, what about you? Have you ever worked on AutoCAD or something like that? Prakash, are you there? You can unmute yourself, no worries. See, if you are interacting with the mentor, then we can teach you even better. Okay, if you are idle in the meet, then it may not be possible to deliver you the complete content. So we are having a plan, but if you respond properly, then only we will be able to proceed. Yeah, who else there in the meet? Yeah, are you? What about you? You have any idea about AutoCAD or Fusion 360? Okay. So if you have see in AutoCAD, we can do some 3D modelings. Okay. See like that. See, if you want to do some construction, let's say see this is actually used by mechanical people. Okay, let's say if you want to work on making a rocket engine, you need to first you need to design those 3D parts in the AutoCAD, including the dimensions. So there are so many things there in the AutoCAD like a front view, top view, side view. So many things are there. So first you will be doing the entire design in AutoCAD. Okay, the construction. If you are an architect, okay, if you are a civil engineer or else if you are a mechanical engineer, so it is actually very useful for them. So where they will be doing the 2D modeling and first they will do the 2D modeling. Okay, the entire construction plan, the entire architecture. Okay, first they will be doing in 2D modeling. Then after they will be converting the 2D modeling into 3D modeling. So after 3D modeling, then they will start actually working on in the field. Okay, like they will start the construction process. The similar case, this is even used in space related agencies like at Sochana or at Indian Space Research Organization or at NASA. Okay, or whatever the space research agency. So these are also used in making uh, engine parts and so many things. Okay, rocket for rockets also we do some 3D modeling. Okay, so see in 3D modeling like these 3D parts, do you remember the file name Gerber? You remember that, Nihal? Gerber, the file extension, I mean the Gerber. Yeah. So if you are, see, after, once you are done with designing the entire PCB, you will be exporting into one file, just like you are sharing an image or PDF with someone else. Similarly, you will be exporting the entire PCB, like the entire PCB project, into single file, which we call it as the Gerber file. Okay. So Gerber is the overall name. It's like one of the format. So, but Gerber contains multiple files, drill files. So many things are there. So just like the Gerber file, okay, which is used for exporting or transferring the PCB related, data. So similarly, the 3D models, okay, these 3D models can be exported into specialized file format, which is called as step. Do you remember? So whenever you come across any file which is having the file extension step, just like for HTML file, it is .html and CSS.css. For Python, it's .py. For image, there are so many file extensions like .jpg, .png, .svg, right? So similarly, whenever you come across any file which is having the file extension .step, .step, or else there's one more file extension which is .stp. Okay, both are acceptable. We are having the two file extensions. One is .step step and another one is .stp. Okay, so both are acceptable. These files indicate the 3D model. Okay, so 3D model. For example, there is something like rocket.step. Okay, so then you need to understand that it is a 3D model, so of the rocket. So if you open that dot step file with CAD tools like AutoCAD or Fusion 360, and when you when you upload, when you import those dot step file, then you can see that entire 3D modeling in a, in a visualization, 3D visualization. You can see the entire rocket. Okay, so dot step file indicates the 3D model. Is that clear? Up to here, is it clear, everyone? So what does dot step indicate? It indicates the 3D model. Okay. So these dot step files are designed in CAD tools like AutoCAD or Fusion 360, which is actually widely used by architects, mechanical engineers, civil engineers for their planning and everything. Okay. So in that CAD tool, we will be doing some 3D models and we will be exporting that file into one specialized file format, which we call it as dot step. Okay, step file or .stp, both are acceptable. Both indicate the uh, both indic both indicate the 3D model. Okay, so why we need to learn about a dot step and all these things? We haven't discussed these details in ECEDA. So but why it is necessary, why it is very essential to learn in KiCAD? Okay, I'll show you. This is actually the drawback of ECEDA. It's not very easy in ECEDA to import the external 3D models and to assign it to a particular component, but it is very extremely easy in KiCad. You can import the external 3D models into PCB design, and lots of interesting things are there than the ECEDA. Okay, we will reveal one by one in during the course. So here, so interoperability. So we are discussing about interoperability from mechanical CAD. So you may be familiar with dot step. So just now I told you what is dot step, right? So IGS is also one similar kind of a file extension. Okay, both are used interchangeably. Okay, so different 3D models are available in step and IGS. So these are actually mechanical structures. Okay, mechanical structures or the 3D design, so which allow interchange of designs between programs for manufacturers. You need to be aware of some of this, as it may affect exchanging designs with colleagues and fabrication houses. So I will just tell you the entire story in very simple. So in KiCad, for each and every component you can assign the 3D model. Okay, so I will show you when we are doing in practical. You will be coming to know how we can import the dot step files and how to assign a 3D model to a footprint. Okay, we'll be learning in detail. Yeah. So there is one more important point now you need to understand. So for PCB design, the story is not quite as good. There is no good schematic plus PCB export, but there are some options. Okay, so that means actually there is no perfect file format for exporting the PCB. Okay, so as day by as days are passing by, we are changing, different file formats are coming. So as of now we are using the standard, Gerber as the standard format for exporting the PCB, which is also called as RX 274X or else 274X2. Okay, RSX2. Okay, this is the Gerber file. This is the short name Gerber. So this is the actual technical term. So this is the current the standard format which we will be using, and many of the PCB design, PCB design tools are using to export the PCB. Okay, there are not only Gerber. So you may wonder, just like for image we will be having different file extensions or file formats. Similarly, in PCB design also we are having so many file extensions like ODB plus plus. Okay, ODB plus plus. This is also one kind of file format, and but the important thing is, unfortunately, KiCAD does not yet support it. Okay, so KiCAD currently it is not supporting ODB plus plus file format. But the KiCAD team, so they have put some executive council meets. So they conducted so many meetings, and they finally decided they are currently planning to implement ODB plus plus, the support for ODB plus plus file format in the version 7. Okay, so in the upcoming version of KiCAD we may expect that it will be supporting ODB plus plus file formats. But as of now, you need to understand that KiCAD does not yet support it. Okay, currently ODB files are not supported in KiCAD. So it may be supported in other formats. I mean other PCB design tools, but in KiCAD it is not yet supported. So what are the other versions which are supported, which are supported in KiCAD other than the Gerber RS274X? Okay, so IPC 2511B, this is also one kind of file format which is very similar to ODB file. Okay, but it is very less widely adopted. So KiCad still supports IPC 2511B, okay, which is also known as GenCAD. So just like RS274X is simply referred as Gerber, similarly this IPC 2511B file format is simply referred as GenCAD or GenCam. So KiCad currently supports GenCAD as well. This is only purely kept for compatibility purposes. So already everyone know that it is already outdated. GenCAD is already outdated. No one is using GenCAD file format to export the PCB. Even the PCB manufacturers are also ceased the support for these some kinds of file formats. They are only supporting the Gerber as the standard file format, but still certain PCB design tools kept it for the compatibility purposes, just purely for compatibility purposes. Other than that, it doesn't serve any specific purposes. Okay, yeah. So hello. Yeah, I hope you can hear me, right? Nihal, you can hear me, right? Okay. Yeah, thanks for confirmation. Yeah, so these are the things. So ODB now we discussed that the Gerber RS274X file format, which is the standard file format. Coming to ODB so many pro level CAD programs support this. Okay, many pro level CAD programs support this, and but unfortunately KiCad does not yet support it. It is planned to be incorporated to support ODB files in KiCad starting from version 7. So we need to wait and see. So coming to IPC 2511B, okay, which is also simply referred as GenCAD or GenCam, which is very similar. This particular file format, GenCAD or GenCam, which is very similar to ODB Okay, so KiCad currently supports ODB files as well. So it is only purely kept for the compatibility purposes. Okay, so similarly we are having a one more one more PCB project export file, which is IPC 2581. So But this IPC 2581 is also currently not being supported in KiCAD. Okay, so this is a problem for some people, very few manufacturers who now demands IPC 2581 rather than the Gerber. Okay, see, compared to Gerber, IPC 2581 is actually the next generation one. Okay, which is very advanced than the Gerber file. Okay, so compared to the Gerber file format, IPC 2581 is the advanced version, even than the Gerber file. So that's why it is rightly referred as the next generation export format. So some of the manufacturers are demanding for the support for IPC 2581, but as of now, it is not being supported in the KiCAD. So we need to wait and see. So maybe it may be supported in the in the upcoming upgradations. So now we will come to another file, IPC D356A. So which is a netlist rather than the PCB artwork format. This is actually netlist file. So don't worry about all this terminology. What is a netlist, PCB artwork file formats? Don't worry about all these things. We will be discussing practically, very practically in the upcoming session. Just wait and see. This is just an introductory session to introduce you the KiCAD and its features. Okay, so there is one more. See this particular, when is the term Gerber? Okay, I already told you in Gerber there are three different main versions. So out of them here two are mentioned. One is Gerber X2. Similarly, there is Gerber X3 as well. Okay, so whenever in Gerber we usually refer it to Gerber X2 file format. Okay, so but there is Gerber X3 file format also. So this is the latest version of the Gerber. Okay, this is also very similar to IPC 2581. See, this IPC 2581 is far advanced than the all Gerber file formats. It could be Gerber X2 or Gerber X3. Okay, so this is the next generation one, IPC 2581. So unfortunately, KiCAD does not support it yet. So few manufacturers are suffering due to this particular thing. However, we can expect it. It is planned to support in the upcoming version. Let's wait and see from the KiCAD team. Whether hopefully they will implement ODB++ files starting from version 7. So coming to the Gerber X3, this is the latest Gerber specification, which is very similar to IPC 2581. Here the important thing is KiCAD now fully supports the Gerber X3. Okay, so KiCAD supports both Gerber X2 and Gerber X3, but it does not support the GenCAD or GenCam, which is also called as IPC 2511B. Sorry, it supports GenCAD or GenCam as well, but it currently does not support ODB++ files and IPC 2581 file. Okay, this IPC 2581 is regarded as the next generation file format. So we already discussed GenCAD or GenCam. This is only kept for the compatibility purposes. Okay, yeah, so these are the important things. So again I will conclude. So we have discussed we are in the introduction to the KiCAD. So we have discussed that KiCAD can be downloaded from their official website by clicking on the download option, and then there is a forum where you post your questions. And KiCAD is open source, unlike Eagle is also open source. So we had a small glimpse of discussion between other programs versus KiCAD. So Autodesk Eagle is also free version is available, very popular. Features are also very similar to KiCAD, but certain features are more advanced in some, and it is also supported. KiCAD is very stable. So even though future upgrades are there, future based, so KiCAD is regarded as the most stable PCB design. Coming to the ARM designer, it is regarded as the professional PCB design tool because it is having certain advanced features like controlled impedance, stack up management, integrated parts database, which are absent in KiCAD. But unfortunately, it requires license. It's not a open source. You need to have a license to use Altium. So coming to the interoperability, we have discussed few important things. The first one we discussed about this .step file or .stp file, nothing but some mechanical 3D files, okay, which can be put into KiCAD. So this is not there in ECEDA, but it is there in KiCAD. And we discussed about different file formats. A project, a PCB project can be exported into different file formats like a Gerber X2, Gerber X3, IPC 2581, IPC 2511B or GenCAD, ODB++. So out of these ODB++ and uh, IPC 2581 are currently not supported. KiCAD or GenCam related files are kept for compatibility purposes, and ODB++ file may be supported from planned to support starting from version 7, and KiCAD fully supports Gerber X3. So these are the important points in the above slides. So now we'll come to a few important things to be aware of in KiCAD. Okay. So actually KiCAD 6 doesn't, so currently we'll be using KiCAD 6 version. Okay, KiCAD 6 does have layer stack up now, and it can be included in basic constraints, but not very good support yet for automatic controlled impedance traces. This is what actually I told. Don't worry about what is this controlled impedance traces, everything. So we will come to know in the upcoming session. So these controlled impedance traces are actually there in Altium Designer. That's what we discussed in the other programs versus KiCAD. Controlled impedance, this is actually there in Altium Designer, but it is not there in KiCAD. Okay, controlled impedance related thing. So already we discussed the lack of IPC 2581 export. So already we discussed this thing in interoperability. So IPC 2581 is the next generation file format to export a PCB project, but it is not yet supported in KiCAD. Okay. So backward or forward compatibility issues. So old version of KiCAD cannot open newer file versions, but new versions can import and migrate old projects. This is very important to understand. So there is some compatibility issue in KiCAD. So if you are using the olden version, very olden version, you might have done some project in very older version of KiCAD. Okay, then you can import that older versions into the latest version. Let's say you did some project in KiCAD 3 or something like that, or older version, and now you want to import that older version into the KiCAD 6. Okay, you can import that, you can safely import that, but you cannot migrate from advanced version or higher version to the backward version. Okay, so backward to forward compatibility is supported, but unfortunately forward to backward compatibility may not be supported. So it's not, you need to check, with that. There are some compatibility issue during the migration of the projects. Okay, and certain functionality needs plugins. Okay, we'll discuss about this thing. So we will see we will see about the one of the good news. So there is a huge community of users. So why use KiCAD? So whenever someone asks you why use KiCAD, so you need to list out all these things. The first one is there's a huge community of users. So millions of people all across the globe, millions of PCB designers all across the globe, even at Suchana. So even you take any space research agency, it could be ISRO or it could be NASA. So they will be also using different kinds of PCB design tools. So these space agencies actually use Altium Designer because that is the professional format, but they still also use KiCAD as the backup plan. Okay, so there's a huge community of users. There's a forum, you can post the questions and you can get you will get a solution for your questions, and it is open source. There is no limits on free version, so no limits on board size or layers, etc. See, if you take the Eagle, so in Eagle what happens, there are some restrictions imposed for the dimensions of a PCB, for the board dimensions, and there is also restrictions imposed on the number of layers that you can use in the free version of Eagle. I mean, uh, yeah, in the Eagle software, Autodesk Eagle, but there is no such restrictions in KiCAD. So whatever maybe, how many number of layers that you want, you can use it. So no matter what's the dimension of the PCB board size. See, every PCB will have some dimension, right? This is the length, so this is the breadth. It will have some thickness, so it will having the three parameters, right? So it will be having the dimension in all the axes. So for there is no such restrictions imposed in the free version in the KiCAD. Okay, there is no limits, you can use as much as you want. There is no restriction in board size or the number of layers, but in Autodesk Eagle there are restrictions. Okay, so though it is a bit more limited than Altium, make no mistake, KiCAD is a professional grade tool only. Okay, So usually Altium Designer is considered as the most professional preferable tool. So, but it doesn't necessarily mean that KiCAD is not used in professional way. KiCAD is having its own important role. It is, uh, you know, as equally as important as Altium. So there's a huge competition going on in the industry between KiCAD and Altium. Both are extremely very good tools. Okay, so yeah, so there's a huge community of users and it is open source. There is no limits on free version you can use. There is no restrictions on board size and the number of layers, and it is also a professional grade tool. Okay, though there are some tools which may not be there in KiCAD and it may present in Altium, but still it is a professional grade tool. And there are some text based file formats. Okay, so like a git version control, we will see all these things in very practically. We'll be doing the experimentation. So every week we'll be having one lab session where I will not be teaching you, so you need to do it yourself. So in fact every day is the lab session. So in this particular course every day is the lab session, no theories, no ppts, nothing. So we'll just maybe the 5 or 10 minutes we'll be explaining you the concept and we'll be jumping into the practical implementation. Okay, the same will be continued for all 28 days. So there will be some text based file formats which we will be seeing in the upcoming session. And there is scriptable. So what does this scriptable mean? So see in Altium Designer, so how many of you know about Pascal language? Pascal. Yeah, someone trying to join the meet. Ibrahim. So Ibrahim, you are a little bit late. Yeah, so how many of you know about Pascal language? Any idea? Pascal? Any idea? You have any idea about Pascal language? So actually Pascal is one of the language. Okay, so this Pascal language can be used in Altium, which see when this Pascal language is used in Altium, it is called as Delphi script. Okay, see actually in ECEDA, those who attended the previous course ECEDA, where we have seen many of the things like we are doing manually. Okay, so many of the things we are doing manually. So in Altium and KiCad, there are some automated tools. So you can automate most of your work. And then also you can do some scripting. So what does this scripting mean? So you will be writing some program. So when you execute that program, this program will be doing certain thing. Let's say you want to place 100 resistors. Okay. So do you think is it feasible? So is it efficient to place these 100 resistors? Let's say you want to place some 100 resistors in a grid. So do you think is it a efficient way to place all these 100 resistors manually in a PCB? So just picking a component and placing it, again picking a component and placing it. So it is not that much easy. It is actually a complicated, sophisticated thing. So we need to look for an alternative approach. So that's the actually that's here scripting enters into the scene. So now it enters into the movie scene. So you will be writing a script. So you design, you will be writing one program, and that program will, when you execute that program, it will be taking care of placing all these 100 resistors in a grid fashion. Okay, so that means are you automating your work or not? Isn't it? You are automating your work, isn't it? So if that scripting functionality is not there, if you want to place 100 resistors, then you need to place it manually. But due to this scripting functionality, you just no need to worry. You will be writing a program. When you execute that program, when you execute that script, automatically the script places all these 100 resistors in a grid fashion automatically. Okay, is that clear, Nihal? Is that clear? Now you understood what does the scripting mean? So this script, so now can you tell me, is this a scriptability, I mean scriptable property, is it supported in ECEDA or not? You might have attended the previous session where we learnt about ECEDA. Is it supported in ECEDA?
No, it's not, sir.
It's not supported. Yeah, that's the biggest advantage in KiCad and in Altium Designer. In Altium Designer, you will be using one variant, a modified version of the Pascal language, which we call it as Delphi script. So using Delphi script, you can automate your work. Okay. So similarly, few functionalities, I don't say all those things which are supported in Altium are supported in KiCad, but to certain extent, we can do some scripting. Okay, not everything is supported, but up to certain extent we can use it. Ibrahim, hi, how are you? I think you are a little bit late.
Yes, sir. I was really busy. That's why I just came.
Yeah. So actually, we will be giving an introduction to KiCAD. So where we discussed about how to install KiCAD, and then we discussed about the dot step file, okay, which is basically a 3D modeling file. So just like for images, we will be having dot .jpg, dot .png. So for 3D models, okay, let's say you want to construct some building or an apartment, a storage house, okay. So first you know civil engineers or these architects first usually they will plan the entire, they will do 2D modeling and they will do 3D modeling in some CAD tools like AutoCAD or Fusion 360. So similarly, if you want to place some 3D model in PCB, okay, for any particular component, this is not actually possible in ECEDA, but it is possible in KiCad and Altium Designer and Eagle and all other softwares, ARCAD and all other things. Okay, so dot step file, whenever you come across dot step file or dot STP file, so immediately Spark should ignite in your brain that dot step file indicates a 3D model. Okay, dot step file indicates a 3D model. So that's the important thing. So whenever you come across any file which is having the file extension dot step, it indicates a 3D model. And then we discussed about other programs versus KiCad. Okay, so Autodesk Eagle is also free version. It is having some advanced features and it is also widely supported. So but KiCad is actually most stable version. Okay, and Altium Designer, uh, it is actually a professional tool, but we require a license. Okay, it is not a free version, it's not a free tool, we require some license. And then we discussed about interoperability. So earlier when you attended the ECEDA course, you learned that PCB project can be exported into Gerber file. So whenever I use the term Gerber, usually it refers to Gerber H2 file format, which is the standard file format. But it doesn't necessarily mean that only the Gerber X2 or Gerber X2 is the only existing file format. There are many other file formats as well through to which you can export a PCB project like ODB++, so and IPC 2581 Gerber X3. And out of these discussion, we came to a conclusion that Gerber X2 and Gerber X3 are completely fully supported in KiCad. And unfortunately, ODB++ is not yet supported. It is planned to be supported in version 7. Okay, and IPC 2581 is also not yet supported. And coming to IPC 2511B or GenCAD file format, it is kept for the compatibility purposes. So and then we are discussing about the important functionalities, important features, the good news that you need to learn about KiCad. So there's a huge community, it is open source, no limits. In Eagle, uh, so in Eagle file, in Eagle tool, okay, Autodesk Eagle, there are restrictions on the board size and the number of layers to be used, but there are no such restrictions in KiCad. So it's completely free, no limits. So sky is your limit. Okay, you can go beyond, even you can go beyond the sky as well. Universe is your limit. Okay, so cosmos, you can go through the cosmos, no limits. So that's why many people are using KiCad. Okay, now you understood. See, everyone cannot, due to some financial constraints, everyone may not be able to afford the licensing fee for Altium. So that's why KiCad is the good to go. Okay, so because no limits, so Cosmos, you can go through the Cosmos. So however, Altium is having some advanced version, I mean advanced functionality than KiCad, but still, so you can go with KiCad. So it is also regarded as the professional grade tool. Okay, and we are discussing about the scriptable, the property scriptable. So in ECEDA you cannot automate certain things, but here you can automate. You can write some Python program, and through that Python program you will be also having some plugins. Okay, and some plugins and processing tools to which through which we can execute a Python program, Python, which is written in Python language, to do some custom operations, okay, custom functions. And the user interface is also pretty good. Okay, so yeah, here one more important thing we need to learn. Okay, this is very essential. So no built-in auto router. Okay, auto routers almost always get everything wrong anyway. Okay, an external auto router free routing is available if you really want it. So by default in KiCad there is no built-in auto router. Okay, in KiCAD by default there is no auto router. It is there in Altium. It is not there in KiCAD. But see, actually most of the times, even if you go with auto router, so most of the cases it will do mistakes. So just like if you are using some AI agents, so at the bottom it will mention that even AI can do mistakes. Similarly, auto router can do mistake. It may sometimes it may go wrong. It may be doing some weird thing, which may lead to catastrophic failure. But still, if you still want an auto router tool in KiCAD, there is something called free routing. Okay, free routing. This is one kind of plugin. So you can use this free routing if you really want it. Okay. Yeah. So up to here, is that clear? Is that clear? Yeah, Ibrahim. Now I will be asking you one question. So is auto routing possible by default? Is there any auto routing built-in auto routing tool in KiCAD by default? Yes, Ibrahim. Are you there? Or else Nihal or Prakash Verma. So anyone can unmute.
No, sir, there is no any built-in
Yeah,
auto
by default there
routing
is no auto
like
routing
it.
tool. However, if you want, you can use free routing. Okay, which is one kind of plugin. You can use that and you can do routing. Okay. Now we will be going into one more concept. Okay. So this is actually very important. So we will discuss. So total this PPT is around 40 pages. So we will be discussing somewhere all the way up to, yeah, up to here, component search engine. We will discuss up to component search engine. We will discuss 13 slides. Okay, so tomorrow I will be taking 2 hours of session. Okay, so today is just an introductory session. Tomorrow we'll be taking 2 hours of session. So in that 2 hours of session I will be completing the other slides. Okay, all other slides other than the first 13 slides, and then I will be making you to install the KiCAD in your system. Okay, I will be making you to install the KiCAD. Yeah, I can see this is the executable file which I have installed 17 minutes ago. It is already installed. So as you check so it is actually occupying something like the executable file itself is occupying 922 MB, so which is approximately 1 GB of your storage. So when you execute this file, it may take even more storage. This only the executable file is taking 922 MB. So now once this executable file is downloaded on your system, just click on that file. Okay, then a setup window will appear. So actually my device storage is already full. Okay, yeah, this is the executable file. Okay, double click on it. So as you can see, now it is verifying the installation. Okay, please wait while setup is loading. So first the installer will be uh, verifying some checksum and all other things. Yeah, so this is the KiCAD setup window. Okay, so currently we'll be using 10.0.4 version. So click on next. So here are some instructions provided. It is not required to close any other applications before starting the installer. Neither is it necessary to reboot your computer. So to few people may see some certain softwares needs to you need to reboot your system in order to do the installation process. But this KiCAD installer, it is not necessary neither to reboot your system or to close the other applications before the installation. So you can directly click on next. Click on next. So actually my device storage is already full, so that's why the executable file is currently may not be running right now. Okay. So now, so make sure that everything is by default, everything will be checked. Okay, if in case everything is unchecked, kindly make sure that you need to tick that and click on next option. And this is the destination folder where the KiCAD application will be installing. So this is the important instruction. So total around 4.5 GB is required. Okay, so right now I'm having 143 MB only. Okay, so let me change. So this PC. So let me, yeah, I'm currently installing in G drive. Okay, because in G drive I have a lot of space. Okay, so around 4, it requires around 4.5 GB. Okay, that's it, just 4.5 GB. So first I will go to my G drive, then in my G drive I will create a folder KiCAD. Okay, I'm going to this PC. So see, already my C drive is already full. I'm going to G drive and I'm creating a new folder. So you can install in whatever the drive which is having a good memory, KiCAD. So there is no need to give the same name. It's just I gave it as part of a normal convention. So I have selected the KiCAD folder. So now after selecting the folder, then only install option will appear. Okay, click on install button. So now installation process will begin. So it will take some time. Okay, so you need to patiently wait till the progress bar is completed fully. So after it is completed, then you can we can start using the KiCAD application. Okay. So if you want to go to the documentation, so visit the official website first, kicad.org, then the first option documentation. Go to documentation. Here you will be having a detailed documentation in PDF format. So introduction, getting started. Okay. So for each and everything, there is a PDF available as well. You can go through those PDFs for if you want more reference. Okay. Everything will be detailedly documented by KiCAD team. You can go through them. So, however, it is not that much easy to understand everything on your own. So that's why I will be teaching you in more simplified fashion, so that you will be able to understand very easily. Yeah. So this is the one more important thing. Okay. So we will discuss about part workflow. Okay, KiCAD part workflow, and they will conclude the today's session. So we'll discuss about part workflow and we'll wrap up the today's session. Yeah, here is one more thing. So this CIAA ACC, which is actually a 12 layered board, so which is having Xilinx 7000 series system on chip and Kintex 7 FPGA, so which is running at gigahertz of speed. Okay, so which means it is running at high frequency. So you can see on your screen, this is actually designed in KiCAD only. Okay, see, very seriously, it is actually no Xilinx 7000 series chip they are using, and it is running at gigahertz of frequency. They are having Kintex 7 field programmable gate array. That means millions of transistors are working together. So the entire PCB, this is designed in KiCAD only. So from that you can understand, uh, you know, uh, there is no limits for KiCAD. Okay. So yeah, we will discuss about KiCAD part workflow. 3D models are being installed. Okay, so by default, few 3D models are installed in KiCAD. So however, if you want to import an external 3D model, you need to do, you need to import the dot step. Okay, I have dot step, right? I've shown you, let's say if you see all these kind of 3D modeling, these are done in, they are exported in dot step files. Okay, so by default it will install few 3D models, but if you want to import some external 3D model, you need to get the not step file of that particular 3D model, then you can import into KiCAD. Okay, so now coming to the KiCAD part workflow. So KiCAD has no built-in concept of part, that is footprint plus symbol. So what does part mean? So part means, see, if you are placing any component in ECEDA, or discuss about part, okay, part number, manufacturer part number, LCSC part. But here, see, uh, I hope you know about difference between footprint and component, right? I will show you what is footprint and component. See, this is the footprint, okay? This is the footprint. See, here there is some copper pads, right? This is the copper pad, this is the copper pad, this is the copper pad, this is the copper pad. So this copper pad and this particular design is part of footprint. Okay, this component which we are having, this is the actual part. Okay, so this will be having the 3D model. So in LCSC, so in ECEDA, so you cannot separately, let's say if you want to place some resistor, so by default when you are placing a part number, whenever you just give a part number, okay, in the library, so automatically a list of components will be displayed, so which are already having some footprint as well as some 3D model. So that means it's not possible to individually, let's say for resistor, certain resistor, you want to change the footprint. Okay, so it is not possible. Or else if you want to change the 3D model, or else instead of this particular IC you want to display it in a different way, it's not possible. So but the biggest advantage in KiCAD is that there is no concept of part. So what does a part do? So part means whenever you are trying to place a component, so that for that component footprints and symbol are predetermined. So you cannot isolate, I mean you cannot individually, let's say for particular symbol you cannot give a, for particular component you can use a different symbol. That's not possible, because all these symbols, footprints and 3D models, they are come with by default in LCSC library. All these are pre-mapped in LCSC library, predetermined. So that concept is not there in KiCAD. So for any component you can use any footprint, and you can design even your own symbols as well. You can design your own footprints also. So this is actually very important functionality which is there in KiCAD. Okay, yeah, see, now installation is already done. So now if I just press Windows option, and if I search for KiCAD, that will appear in the apps list. See, KiCAD is already installed. Okay, so now I will be launching the KiCAD. Click on finish, it will launch KiCAD. So now you will be seeing the first user interface, how KiCAD will look like. Welcome to KiCAD 10.0. So KiCAD is starting for the first time, or some of its configuration files are missing. Okay, that means if we are launching this KiCAD for the first time. So you can go with the default settings, click on next option, again next option, click on finish. So this is the user interface of KiCAD. Okay, this is the user interface of KiCAD. I'm putting I'm maximizing my screen to full screen window. Yeah, I hope still you are able to see my screen, right? Can someone just confirm me? Actually, my device is little bit lagging, so due to storage. So can someone just confirm me? Are you able to hear me?
Yeah. We can see your screen.
Yeah, you're able to see my screen, right?
Yeah.
Sure, but still I think Okay, so I'm just opening KiCAD again. Yeah, this is the user interface of KiCAD. Okay, the first option is schematic editor, second one is symbol editor. See, these are all these options like footprint editor. This is not actually there in ECEDA. So we are having Gerber viewer. So if you are having any Gerber file for any PCB, you can directly click on Gerber viewer. Okay, it will ask you to select one file. You can select the Gerber file and you can see the PCB in 3D view, 3D orientation. So this Gerber viewer is not actually there in ECEDA. Okay, there is no option for Gerber viewer in ECEDA.